In this video, we're going to be looking at solving systems of linear equations, and we're going to do a brief intro and then focus mostly on applied problems. Let's first talk about what it means to have a system of linear equations. First, we see that word linear, so we know we're not going to have any quadratic or any other type of equations. They're all going to represent lines. And the fact that it's a system of equations, that means that we have multiple equations. Now, typically, we're going to have things like maybe we have 2 variables and 2 equations, or maybe we have 3 variables and 3 equations. We can, however, change that number of equations or the number of variables so that they're not equal. Maybe we have 2 equations and 3 variables. Maybe we have 4 variables and 5 equations. Depending on how many equations and how many variables we might have different types of solutions. When we're trying to find a solution to a system of equations, here's an example of one of my systems. What we're trying to find is the values of x and y, or the ordered pair, that solves both equations. So if I plugged x and y into this first equation, I would get a true statement. If I plugged it into the second equation, I would also get a true statement. Graphically, if I graphed this system of equations, the first equation would give me this red line, and the second equation would give me the blue line. If we're trying to find a x and y value that solves both of these equations, remember any point x, y on this line here is going to solve this equation. Any point xy on the blue line is also going to solve this second equation. So if we're trying to find a point that solves both equations, we're trying to find a point on both lines, or the point of intersection. So we can tell from our graph here that the solution to this system of equations, the x value would be 4 and the y value would be 3. And if you went ahead and plugged this into our system of equations, if we plug it into x plus y equals 7, we would have 4 plus 3 equals 7. Yep, that's true. And if we plugged it into 2x plus y equals 11, you'd have 2 times 4 plus 3. This does equal 11 because I'd have 8 plus 3, which gives me 11. So again, true. There are 3 types of solutions that we're going to see in these systems of equations. We could have just one solution, like we had in the last example where we have 2 lines that intersect. But sometimes our 2 lines actually don't intersect. And if that's the case, then there's going to be no solution. The last type of solution we can have is infinitely many solutions, and notice here I only see one line. So sometimes when we're given a system of equations, maybe we have that x plus y equals 7, but the second equation is something like 2x plus 2y is 14. Notice that this second equation is just this first equation times 2. So even though it looks like it's 2 different equations, it's really just the same equation. Frequently, we're asked to write a solution, and what we would do is we would just take our equation and solve it for one of our variables. So maybe I solve this for y. I'd have y equals 7 minus x. So then the ordered pairs would all look like x and 7 minus x. Anything that is of that form is going to solve that equation. I could also solve this for x. I'd have x equals 7 minus y, and so then my points would look like 7 minus y, y. So it's just 2 different ways of writing the solutions to the same system of equations. Now typically we're going to have 3 different methods for solving these things. The first method that we kind of saw was that graphical method, but that graphical method really only works well when, first of all, we can visualize it, so we only have two variables, and second of all, it really only works when I can find where that intersection point is. And so, you know, if it ends up not being at whole numbers or integer values, it's going to be harder to estimate. So this graphical method is not particularly useful in general. So the 2 methods that we're going to focus on are the substitution and elimination method. Now there's many videos on solving systems using these 2 methods. In this video, I'm just going to assume that you have seen those methods, and then we'll run through them quickly. But if you want a more complete and slower explanation of this, you should look at another video. What we're going to focus on in this video is solving applied problems. And when we have applied problems, we're looking at problems that are given to us in terms of stories. So we don't necessarily know what our system of equations are. And we have to come up with that system of equations, and then once we have it, then we solve it. There's 4 steps that I typically take with these. The first thing I want to do is define the variables. Now, it might seem like this isn't important, but it is really, really important. Once we define the variables, we're going to determine what types of information we're given and organize it in some sort of fashion. I like to put it in a table. Next, we're going to write the system of equations and use one of our methods to solve, either elimination or substitution in this video. And finally, we'll state our solution in a complete sentence with appropriate units attached to all numbers. Let's look at this first example. Jose has $50,000 he wants to invest in CDs and bonds. He can earn 2% per year in a CD and 7% per year in a high yield but riskier bond. If Jose needs an annual income of $25 from his investment, what is the smallest amount he can invest in the high yield bonds? When I'm reading through this, the first thing I'm thinking of is what types of information am I given and what is the question that I'm being asked, and that question is going to help me define my variables. So looking at the last sentence, frequently I can determine the question that I'm being asked, and this will tell me what my variables need to be. So it says, what is the smallest amount he can invest in the high yield bond? We need to know how much he's going to invest in that bond. And we're going to start, instead of by answering the smallest part, just let's figure out how much would he have to invest just so to get that exactly the $2,500. The bonds earn a higher percentage rate, so the more he puts in the bonds, this is going to go up. Let's start though by finding what is the minimum amount, or what is the amount that he would put in the bonds in order to get exactly that $2,500. My C is going to be the amount in dollars invested in the CD, and my B is going to be the amount in dollars invested in bonds. When I'm trying to organize my information, I frequently have information about different variables. So I have information about my CDs, I have information about my bonds, and there's typically some sort of information about the total. In this first part of the sentence where it says Jose wants to have $50,000, this gives us information about the total invested. We know we're going to have C dollars in the CD, B dollars in the bonds, and that's going to give us a total of $50,000. This can make an equation. This C plus the B has to equal $50,000. Next, we have information about how much he's earning. He's going to earn 2% per year on the CD and 7% per year on the bond, and that's going to give us a total of $2,500 in his investment in terms of earnings. If he's earning 2% per year on the CD, then to find the total amount that he earns from the CD, we would take 2%, or 0.02, times C. That would give us the amount of investment income he gets from the CD. He's going to have 7% for the bond, so the amount that he's actually going to earn from that bond account is going to be 0.07B, and we know that the total that he wants is $2,500. The amount that he's earning from the CD plus the amount that he's earning from the bonds, that has to total to $2,500. Now we're ready to solve the system of equations. I basically had this system here written out in my table form. C plus B is 50,000, and 0.02 C plus 0.07 B equals 2,500. And we have our 2 methods that we tend to use, elimination and substitution. Substitution works really well if you can easily solve one of your equations for one of the variables without having fractions or decimals that are more complicated to deal with. If I look at this first equation, I can very easily solve that first equation for either C or B. The second equation might be more complicated to solve for C or B because I'd have to divide by that coefficient. So in general, if I have a coefficient of 1 or -1 in front of one of my variables, then that makes it easy to solve for that variable. We're only going to use this substitution technique when I can easily solve for C or B. If I can't, then I'm going to use the elimination. This particular example, we're going to solve using substitution. Now with substitution, we're going to solve for C or B. So I'm going to solve for C. C is going to be 50,000 minus B. And then I'm going to take this and substitute it into my second equation. In other words, I'm going to take that 50,000 minus B and I'm going to replace the C here in my second equation with the 50,000 minus B. Moving up over here where I have a little bit more space, I have 0.02 times 50,000 minus B plus 0.07b equals 2,500. I'm going to distribute the 0.02 across both terms. When I do that, the 0.02 times 50,000 gives me this 1,000 minus 0.02b plus 0.07b gives me 0.05b. I'm going to subtract 1,000 from both sides, and I have 0.05b equals 1,500. Divide by 0.05 on both sides, and I get b equals 30,000. Now, in this particular problem, they didn't ask us for both values, but sometimes I am asked for both values. If my b is 30,000, plugging that into this equation over here, 50,000 minus 30,000, that would give me my C is 20,000. The last thing we need to do is state our answer in a sentence, and I want to look at the original question here. So just look back here. It says, what is the smallest amount he can invest in the high yield bond? Our answer to this question is that Jose needs to invest at least $30,000 in the high yield bond. One thing to note is that it says here we need to make sure to include appropriate units. In this problem, that just means I need to make sure to say that this is $30,000, not 30,000 CDs or 30,000 bonds. It's $30,000. Let's look at a second problem. A landscaping company placed 2 orders with a nursery. The first order was for 13 bushes and 4 trees and totaled $487. The second order was for 6 bushes and 2 trees and totaled $232. The bills do not list per item price. What were the costs for 1 bush and 1 tree? So if we look here, this last sentence here is the question that we're supposed to answer, and that sentence tells us how to define the variables. We need to know how much we're going to pay for 1 bush and how much we're going to pay for 1 tree. My variables are going to be B is going to be the cost or price in dollars for 1 bush. T is going to be the cost, and we're thinking really a price for 1 tree, again in dollars. Looking back at the information that we were given, we have information about our 2 orders. The first order was for 13 bushes and 4 trees and totaled $487. So once again, I'm going to organize my information in a table. I'm going to have information about bushes. I'm going to have information about trees, and I'm going to have a total. And this first sentence, the first order, this is all about order number 1. So my first row in my table is going to be all about order number 1. Order number 1, we ordered 13 bushes and we ordered 4 trees, and that totaled $487. This isn't quite the correct equation. Well, it's not an equation at all, but it's not quite correct yet. We know we're ordering 13 bushes, so the total amount that we paid for the bushes was 13B. We know we ordered 4 trees, so the total amount that we paid for the trees is going to be 4T, and so when we add those together, that should total up to that $487. Try the second one. Can you get the correct equation? Our second equation for order number 2 is going to be 6b plus 2t equals 232. Here's my system of equations, and I need to think about what method I'm going to use to solve this. Now, in the last one, we used substitution because we had the coefficients of one of our variables being a 1 or a -1, and so it was very easy to solve. This one is a little bit more complicated in that we never have a coefficient of 1 or -1, so it's not as easy to just solve for one of the variables. I would probably end up, or I might end up with fractions, and whenever that happens, it makes the solving process can become more tedious. Instead, we're going to use a different method called elimination. With elimination, what we're going to do is we're going to add our equations together, but we want to do that in a way that one of our variables is eliminated. In order to make that happen, we need to make the coefficients of one of either the b or the t be exactly opposite each other. And one thing we can do to make that happen is we can take one of our equations and multiply by a number. In this system of equations, it's going to be easiest to make the coefficients of the t be opposite in sign. For instance, we could take this second equation and we could make the coefficient be a -4 here by multiplying by -2. Doing that would give me 6 times -2 is -12, 2 times -2 is the -4, -2 times the 232 is -464. Now, when I add these together, the 13b and the -12b just gives me 1b. The 4t minus 4t, that just gives me 0. And the 487 minus the 464 gives me 23. So I've actually solved for the variable b. Now, to find my other variable, I still need to find t, so I can take my b and plug it into either of my equations and solve for my t. I'm going to use the second equation. My second equation was 6b plus 2t is 232. When I plug in my 23 for my b, I'm going to get 6 times 23 plus 2 times t is 232. 6 times 23 is 138, and I have the plus 2t is 232. All I need to do is subtract 138 from both sides, and I have 2t is 94. Now I can divide by 2 and I get t is 47. So I have found the value of both b and t that make both of my equations true. All I have to do is write my answer in sentence form. And we get each tree will cost $47 and each bush will cost $23. And again, the units here are important, and in this situation our units are those dollar signs. That's it for this video. Hopefully you found it helpful.